Good morning to everyone. MT8791 Embedded System Design, final year, 7th semester, Mechatronics, Regulation 2017, Unit 1, Introduction to Embedded System Design. So in this slide, as we seen in 5 parts in the earlier videos, so we are going to, we have seen there are lots of embedded system design process, design methodology, and processor and design and IC technology and hardware software co-design process. Okay, so in this slide, this video, we are going to see about the performance of hardware software co-design process. Okay. So the memory and processor sensitive software, the allocation of address to memory, program and segments and devices. So the functions and the process and the data and stacks for various segments and memory. So the program routines and the processes can have a different segments. For example, a program code can be segmented into each segment stored in a different memory blocks. So as usual, we have, if we are comparing on program in the sense, definitely we are having the assembler, loader, linker. So assembler will convert that program into machine level languages, assembly level language into machine level language. So it will convert a digital address for that. It will convert that symbol tables. So that symbol tables will be linked by that linker. So finally, it will linker. Loader will perform that particular operation and finally give a output. So there will be different segments at the memory for the functions and process, like a task and threads. Okay. So in that environment, usually we are using in a embedded system, we are using a multitasking environment. So multitasking environment means we have using that variety of task scheduling and deadline process and process and threads. Okay. So in this slide, so hardware sensitive programming, so processor sensitive, memory sensitive, and what are the other data sets. Okay, so memory for using these slides. The next one is performance of the accelerators and what are the accelerators. So up to this, I'm going to complete this slides. Okay, so these are the agenda about this process, about this presentation. Okay, so processor sensitive, the processor has different types of structural units. It can memory mapped IO or IO mapped IOs. So the IO instruction are processor sensitive. So the processor may be fixed point ALU only. The floating point operations, when we needed, are handled different than processor with the floating point operations. A processor may not be provide a execution of single instruction and single multiple data and a very large scale instruction word instructions. Okay, memory sensitive means a program is a video processing and a real-time video processing. The picture resolution actually used for the processing and the number of frames per second. Okay, so if a large memory is available, in the sense high resolution pictures can be processed. Okay, so the memory addresses of the IO devices registers, buffers, control registers, and vector addresses, and interrupt sources, interrupt service routines. So these are called the memory devices, memory sensitive programming devices. Okay. So the next one is the other data sets which are used for the memory, in the sense a string as usual, a circular queue and one-dimensional array, a table and hash table, lookup points and a list. So these are all the programming units when we go for to combine on embedded systems by means of various programming methods. So as usual, we have seen the assembler, loader, linker. The assembler will convert that particular program into that particular symbol table. So that's why they have included that name called a table, a two-dimensional array with the memory blocks. So all the symbol table will be converted into a link table. So lookup tables. So that's how we have used that lookup tables, points, values. So all that links are loaded into the particular loader application. Finally, it will give a particular applications. Okay. The next one is how we measure the particular performances. Okay. So the system performance index, the performance of the finally developed embedded system is a measure of success. Its performance of each life cycle of the development process is instead of following each record functions must show after the test its characteristics. Okay. So first we have to measure the final system implementation. So we have to test the performances. Okay. So that's the performance modeling. The second one is multiprocessor system performance. Variety of multiprocessor we can use. So we have to measure the performances by the multiple multiprocessors by means of the optimized scheduling of an instructions, whether it meets as particular time constraints, The next one is MIP and MFlop and the DMIPS performance indexes. So MIPS stands for million instructions per second. MFlop stands for million floating point instructions per second. The next one is distort seconds. So how much seconds it meet the processor performance, how much instructions per executions is meet the particular processor performance. The next one is EDN embedded benchmark consortium. So how a five benchmark of a system, telecommunication, consumer electronics, automotive industrial electronics, and office automations, consumer electronics. It is used for measuring, comparing the system performances. Okay. So the performance metrics, buffer requirement, IO performance, and the bandwidth requirements. The real-time performance means the metrics which are used for ratio of some interrupt latencies and the CPU load and worst case time analysis for the communications. Okay. Then last slide, we have to analyze the system throughput and latency for the system response and delay jitters. If it jitter means if you present any allegations or something component which is not working in a proper time and in the sense that's called the jitters. The next one is performance accelerators, convert control data flow graph by means of various abstractions to perform some computational calls. So reusing the memory appropriate variable selections, using a stack of data structures in a feasible queue for a list of selections. So computing slowest cycle life cycle, and we have to fetch the RAM and ROM multiple bytes. So the coprocessor will be used for some additional processor which not done by the main processor. We can use some coprocessors. So likewise, we are measuring the hardware software code design process. So that's it. I have completed the first unit. Thank you.